Hello everyone! This is my first time using this app, so bear with me. But I'm going to go over the examples and the notes for 8.5 so you can use it to study for your quiz on Thursday. Yeehaw! Alright, so here we go. An ascribed angle is an angle with its vertex on... Oh boy. Not a good start. On the circle. So the vertex is right here. That's going to be B. And its two sides are chords. So here's its sides. Doink. Doink. There we go. So there is our inscribed angle. Vertex on the circle, two sides that are chords. All right, so the intercepted arc is the arc that lies between the what? Endpoints of the inscribed angle. Endpoints. Change the color because I'm going to show you what the arc is. So the arc here is between the endpoints right there. That's called the intercepted arc. The measure of the inscribed angle is equal to half the measure of the intercepted arc. So before we did, let's do a different color here, green. Before we did the central angle, we knew the central angle with the intercepted arc was the same. But the inscribed angle is half of the central angle and half of the intercepted arc. So we write it as the measure of ABC here, ABC is, let's erase that a little bit, is half of the arc. So, dunk. 1/2 of the measure of arc AC. There we go. So there is what an inscribed angle is. Its measure is half of the arc it is inscribing. So what is an intercepting? What happens when it intercepts a diameter? That's the other part. So we have a vertex on the circle. Here is its intercepted arc. So let me show. Let's go purple. Ooh. Isn't this app cool? All right, so here's the intercepted arc. So we know the inscribed angle is half of the diameter. So if the diameter is how many degrees? Diameter equals 180 degrees. So what is half of that? 90 degrees. And what is it? What kind of angle is a 90-degree angle? It's a right angle, which is pretty cool. If we move this vertex anywhere around the circle, as long as its arc is the diameter, it will be a right angle. That is cool. If we have two inscribed angles and they intercept the same arc, so I'll show you what that looks like. So we have, here's one angle. Let's get red. Here is its arc. And then we have another intercepted angle, go green. And do you see that they have the same red arc there? That tells us something. That tells us that these inscribed angles are congruent. Which means the measure of ABD, so ABD, yep, ABD. Oh, they did it the other way. Whoops. Yeah, there's other arcs as well. So let's go back. Ding, ding, ding. So they did it this way. So they did this arc, this intercepted angle, and this intercepted angle. Doink, doink. And they both share an arc as well here. It's the same thing. So ABD is going to be congruent to the measure of ACD because they are inscribed angles and they share the same arc, which means they are congruent. Same as if we had a central angle that had the same size arc. Okay, so let's do some examples. I'm going to do all the odd ones. And when we get to class and you guys have any questions, I can go over any more of these if you need. So here we go. So number one. First, it's asking for what is the measure of WXY. So the angle measure of WXY. What information does it give us? It gives us the arc. Arc is 62, which means this angle, this inscribed angle, so the measure is going to be half of the arc. What just happened? Pretty cool though. I'm gonna have to learn how to do that. Measure of WY's arc. So what is half of 62? 31 degrees. That's not degrees. There we go. Pretty easy. Not bad. Number 3, same thing. We're finding PQR. So we're finding this inscribed angle. So its endpoints are here. So where is its arc? Its arc is this. Oh, the arc is the diameter. We know that diameter is 180 degrees. And we know inscribed angles are half of 180 degrees. So we know PQR must equal 90. And we showed that before, over here. Okay, let's try again. Number 5. All right, it's giving us KL's arc is 65, KJ's arc is 53. It's asking for this inscribed angles measure. All right, do we have enough information? We do. We need to first find what this arc measure is. And we can find that because we know it's going to be, red is going to be equal to, that's a little too confusing. I'll just write it out. So we have the measure of LMJ is equal to 360 minus 65 minus 53. Because we know that all the arcs around the circle equal 360 degrees. And that means it equals 242 degrees. So this arc measures 242 degrees, which means JKL must be half of that. And half of 242 is 121 degrees. There we go. All right. Number 7. Let's change color again. Experimenting, see which color I like best. Number 7, solve for x. We know that this inscribed angle right here is going to be half of its arc. So we could write it as half of 158 equals 8x minus 9. That's one way you could do it. Or you could write it as, let's see if I can show you guys something cool. Here we go. Whoop. Move that to the side, maybe over here. And then another way I could write it is 158 equals 2 times 8x minus 9. Now I like the other way better, so let's do it that way. Doink. And doink. I'll move that back. Okay, so here we go. Let's solve. What is half of 158? That's the question. It is 79. 79 equals 8x minus 9. Solve for x. 8x equals 88. X equals 11. Are we done? Yep. It says solve for x. Check. There we go. Okay, number 9. Ooh, okay, this looks familiar. We have an inscribed angle, vertex on the circle. Where are its endpoints? The diameter is between its endpoints. Let me change colors here. The arc is the semicircle. So we know something very special about this. We know 13x minus 1 equals 1/2 of the semicircle's measure, which is 180 degrees. So we can solve for that by saying 13x minus 1 equals 90. 13x equals 91. X equals, what is that, 7? Yeah, and we're done. Okay, number 11. We have our intercepted arc. Vertex on the circle, endpoints on the circle. Chords are its sides. Here we go. All right, we're given the intercepted angle to be 7x minus 10. The arcs around it are 162 and 92, which means this arc, let's change it to hot pink, woo, is going to be, uh-oh, what happened? What happened? Oh boy. Okay, there we go. Oh no, got rid of my hot pink. There we go. Which means arc AC right here is going to be equal to 360 minus 162 minus 92. Which is, say hi to Mr. Zach.
Hi, Dustin's class.
This is just like a pre-recorded video I'm going to send to them. The other class, I'm just waiting on questions or anything like that.
I was just gonna say, just let me know if you need anything, okay?
Okay.
Yeah. Yeah. All right.
Appreciate it.
You got it.
All right, guys, let's do this. So we get this angle to be this arc to be 160 degrees. So if that arc's 160 degrees, we know the inscribed angle is going to be half of 106. So 7x minus 10 equals 53. Let's make this a little bit smaller. God, I love this tool. Whoa, got the other one from the, oh boy. Let's try that again. Okay, let's move that up. Let's make this bigger. I'm getting the hang of this. So 7x minus 10 equals 53. So we know 7x equals 63, which means x equals 9. Boom. Done. Why did this get fatter? Weird. I'm going to go skinnier now. Okay. Number 13. Here we go. Sticking with hot pink. Number 13. The measure of FGH is 6x plus 21. So 6x plus 21. We know the measure of arc FJH. So FJH is 17x minus 28. Find the measure of FJH. Okay. Since we know there is a relationship here, we know half of the arc equals the inscribed angle. We can solve. So another way of writing this, get rid of the 1/2. I just multiply 2 by both sides. I get 17x minus 28. And then I get 12x plus 42. I just multiplied this side by 2 and this side by 2. Remembering that an equation is like a scale. If I do one thing to the other, I can do the same thing to the other, and it'll go back to being balanced again. So here we go. Let's get the 12x to the left here. We get 5x minus 28 equals 42. Get the 28 to the right. 5x equals 42 plus 28 is 70. So this is an x. So 70 divided by 5. What is that? Can you do that in your head? It is 14. So, are we done? No, we have to actually find the measure this time. So the measure of FJH is going to be 17 times 14 minus 28, which is going to be 210 degrees. And there we go. How many more have we got? Last one. Woo! Number 15. It's giving us ABD. ABD. So this inscribed angle right here. And ACD. Let's change colors. Orange. ACD. Find arc AD. So this arc right here. Ah, they share that arc. See that? Each of these inscribed angles shares that arc. So that must mean the inscribed angles are congruent. So we can set them equal. So let's do that. 6x plus 26 equals 13x minus 9. So we get 26 equals 7x minus 9. And then we get 35 equals 7x. And then x equals 5. Not done though, because we have to find the measure of AD. So, measure of AD is equal to 2 of the inscribed angles, or half of AD equals that. So let's write it a little bit different. Oh. Let's first just find the measure of ABD, actually. That would be easier. Just find the measure of one of them, and then we can double it. That's the easiest way to do it. So, measure of ABD. Measure of... Oops, gotta get my pen back. Let's go red. The measure of ABD, angle measure of ABD, is going to equal to 6 times 5 plus 26, which equals 56. And we know the arc. So we know the arc AD is going to equal 2 times 56, which is 112 degrees. Check. Done. All right, guys. If you have... Oh, no. We still got more. I forgot. Inscribed quadrilaterals. Here we go. If a quadrilateral is inscribed in a circle, then its opposite angles are what? Inscribed means each of its vertexes is touching the circle. Okay. Opposite angles are supplementary. What does supplementary mean? Remember. Supplementary means the angles add to 180 degrees. Sup, like you're holding your arms out, telling someone what's up. Looks like a straight line. A straight line's 180 degrees. All right, so for example, A and C are not congruent, but they do add to 180 degrees. So we say measure of angle A plus the measure of angle C equals 180 degrees. And we also know that the measure of angle B plus the measure of angle D equals 100 degrees. The reason we know that is because if a quadrilateral means a shape with 4 sides, is inscribed in a circle, such as this, it's being inscribed in a circle, then its opposite angles, so this and this, are supplementary. Meaning these two angles add to 180, and these two add to 180. There we go. So knowing that, we can solve these quite easy. If we have J, we're looking for J, so we're looking for J, and we know its opposite angle is 92. So we can say 92 plus x equals 180, which means J equals 88 degrees. Same thing for K. Let's change colors. 45, call it Y, plus Y equals 180 degrees, which means K is 135 degrees. Okay. Part 3, number 3, is going to be using inscribed angles and what we just learned with inscribed quadrilaterals. So it's telling us arc BC is 61 degrees. Arc AB is 39. So we can find lots of information here. What's the measure of angle D here? Well, it's half of its arc, and its arc is 39 plus 91. So for D, 39 plus 91 gives us what? Yeah, 100. So half of 100 is 50. Very good. Now we are looking for angle C. So let's get rid of this. And now we're looking for this. Ooh, get my pen back. Now we're looking for this. So we have our vertex, we have our endpoints. The arc we're looking for is here. So how do we find that? Good question. Think about it. So we know 61, 39, 147. So the only part of the arc left is what is what? Remember, the whole thing has to add to 360. So it has to equal 152. So this is 152. Can't see that very well. 152. Sorry. The whole thing is 152. So this is whole 152. This part is going to be 113. Yeah, 113. Check your answer. 113 plus 39 plus 61 plus 147. Does that give you 360? Should. And so, angle C is using this arc. That's its arc. So it's going to be half of 113 plus 39. So half of measure of angle C equals half of 113 plus 39, because that's its arc. So that is 152. Half of 152 is 76. Very good. Now we're looking for angle B. Angle B. Here is its arc. Oy, that was not good. Angle B. Described angle B. Its arc is here. So we take this arc right here, so this degree and what we put here, and we add them together. That is going to give us 260. 260. And 260 divided by 2 is 130. So that's going to be angle B. And last one, angle A. Angle A is this guy right here, inscribed angle A. And its arc, I'm not using yellow anymore, it's not very good, is here. So it's going to be half of 61 plus 147, which is 104 degrees. There we go. Number 3, we're done. Number 5, we have a quadrilateral inscribed in a circle, and we have 2 opposite angles, which means they add to 180 degrees because they are supplementary, which means we get negative 5x plus 195 equals 180, because I combine like terms. 62 and 133 is 195. And then I get negative 5x equals negative 15. Subtracted the 195. And x, when you divide by negative 5, a negative divided by negative is a positive. And negative 15 divided by negative 5 is also a positive. So x equals 3. And we're done. Very good. All right, number 7. And our last one. Ooh. All right, so number 7. We have 12x minus 25. We need to find h, because if we find h, we know they're supplementary. Can we find h? We can. So h is an inscribed angle, and its arc is 50 and 96, so 146. So the measure of angle h equals half of 146, because that's 50 plus 96. That's the measure of the arc GI. So what is the measure of h? Half of 146, which is 73. So since we have that, we know 73 plus 12x minus 25 equals 180. So 12x plus 48 equals 180. 12x equals 132. And x equals 11. And we are done with this section. So I want you guys to work on the giant circle challenge and 10-5 homework, all of them. That will be due Thursday before class. And we are going to be having a quiz on Thursday as well. So that's it.